Good morning. In today's session, we are going to learn about theoretical relational languages, that is, relational algebra and relational calculus. This comes in the basics of relational database management systems. Going back into the presentation, first of all, relational algebra. Relational algebra is actually the background of your SQL. It is actually a procedural language, and it acts as an interface to the data stored in the database. That is, what database it is being stored, it acts like an interface, and its background is based on mathematics, so that your SQL operations are are executed in a very short time duration. Actually, you'll be learning about relational algebra in detail, and you'll be learning about relational calculus. You'll learn relational calculus introduction alone. Okay, then you'll be learning about first going back to your relational algebra. Relational algebra, you'll be learning about operators. There are a number of operators are there, and you'll be learning about the operators which are related to relational algebra, so that your SQL, all the background of your SQL operations are from your relational algebra. Okay, important terminologies. There are important terminologies which you have to know. The first one is relation. A relation is actually a set of tuples. A tuple is actually a row in a database table. A relation is, you'll be having a set of tuples, means then you can call it as a relation. The next one is tuple. A tuple is a collection of attributes which describe some real world entity. Suppose a real world entity, it will be having a collection of attributes. For example, some details about an employee. All these things will be coming under one particular record. Then attribute. An attribute is actually a real world role played by a named domain. Actually, you'll be having one particular person and a student ID, a student mobile phone, a student address. All these things are attributes. And a domain means, for example, project is one domain, and then delivery, that is sales and delivery, is another domain. Suppose if you want to perform two operations, as for example, if you want to perform union operation between two tables, means both of the table should be of the same domain. For example, project, the first if you want to union two tables, means the two tables should be having the same degree as well as the same domain. Otherwise you cannot perform union operation. And then the next one is set. Set is actually a mathematical definition for a collection of objects which contain no duplicates. Okay, going back inside. Then what are the operators which are concerned with write? There are three operations: insert, delete, and modify. There are operators which are concerned with retrieval, which is data retrieval. This is what you're going to learn. Operators, that is union, intersection, difference, and Cartesian product. These are the operators which are concerned with mathematical set theory, that is set theory based relations. So I'm categorizing under mathematical set theory based relation and special database operations, namely selection, projection, and join are special operations. Apart from that, you'll be having one more which is called as division, which also comes under special database operations. Totally we are having, how many operations are there? There are nine operators which are present in relational algebra. They are union. Union means you are going to take both the tables, and you're going to take all the entries, both table entries. This you'll take both the table entries regardless of its, it should be of the same, that is union, it should be union compatible. Then the next one is intersection, the opposite of union. And then difference, projection, selection, product, then assignment, join, and the last one is division. All these nine are coming under relational algebra. Okay, we are going for selection here. Selection is actually, it is the other thing is actually, it is an operation. It is used to obtain a subset of tuples of a relation that satisfy a select condition. For example, if you want to find all the employees born after 1st January 1950, you're going to give a select query. So you have a big database table, and which you want to take one specified entry of that particular employee. Then you will give a particular condition. Based on that condition, it will select that particular. So it is called a selection, or you're going to call it as horizontal selection. Select database, that is a DOB, date of birth. You're giving the date format 01 January 1950, and you're going to tell that what is the table is employee. So it will check for the database, in the database, that who's having the DOB 01 January 1950. That entry alone it fetches and it returns back. So this is called as that is a horizontal selection or selection. Then the other one is projection. Projection is the other way. It is a vertical selection. Okay, the projection operation is used to select a subset of attributes of a relation by specifying the names of the required attributes. So what happens means, you will be giving project is a table name, surname, and employee. You'll be having many columns. You are selecting only what surname and employee number alone in the table, which is employee. So that alone, that columns alone will be displayed, the other columns will not be displayed. So it is coming under vertical slices. And there is, what is the difference between selection and projection? As I told you, selection is actually horizontal slices. It takes the value which you are searching for, the important information that you are searching for, that is horizontal slices. The other one is projection, which is the, you're selecting the column and it displays that column alone, that is vertical slices. Selection, you'll be using sigma. Okay, the select operation is used for selecting a subset of the tuples according to the given selection condition. Projection is given by phi. Projection eliminates all the attributes of the input relation but those mentioned in the projection list. The selection and projection, you can combine both. For example, if you're going to get the list of the employee numbers for employees in the department number 1. Department number 1 means you are specifying it is a projection. Okay, list of employees. You're going to give the condition also, you're going to give the column also. So you're combining projection and selection in this case. The other one is projection. Projection operator extracts specified attributes or columns from a given relation. For example, if you want to specify what column, for example, the student name, age, that alone will be displayed. Whatever column you want, that alone will be displayed. Then the other one is actually called as join. Join is actually, what is it is, you'll be having a common column. You'll be taking two columns, two tables, and you'll be having a common column. For example, you're taking order and you're going to take product. Order number will be there, and here also product, the you'll be having order number will be there. You're taking both the columns together. This column common, you'll be having some common columns between two tables, and using that common column, you'll be combining one table with another table, which is actually join. Then the other one is product. Product is actually, the other name is called as Cartesian product. The product operator builds a relation from two specified relations. It consists of an possible combination of tuples, one from each of the two relations. You will combine and then you will take the product. All the entries will be displayed. Whatever is there, it will take a product, it will combine two tables and it will display. Here duplications may be there. Okay, product is actually what it is meaning is Cartesian product. It will combine all the entries. Suppose if it is there in one table, it will display that. If it is in the other table, the same entry, that it also will display. Disadvantages, it will have lots of duplicate values. Union operation. Yeah, union operation, it is an operator which builds a relation from tuples appearing in either or both of the specified relations. It will combine. Okay, to be union compatible, it should have the same type of attributes, sets of columns having the same data types, that is domain. For example, you're taking two tables, one is A, the other one is B. One is having the roll number and the names of all students whose major discipline is computer science. You're specifying here, you're taking A class and you're taking B class.
and then you're combining both. What are the entries are there in both A and B, both will be combined, and it will be displayed as you need. That the only thing is the domain should be the same, and the column, that is the domain should be the same, and the number of columns also should be the same, that is the degree. Then we have come to the end here. We will tell about something about relational calculus. Relational algebra is a procedural language, whereas relational calculus is not a is a non-procedural language. In relational calculus, a query is expressed as a formula consisting of number of variables and an expression involving these variables. And you're going to, it is in your DBMS, these, it transforms the non-procedural queries into equivalent efficient programming queries. Okay, this is one advantage here. The relational calculus is used to measure the selective power of relational languages. A language that can be used to provide any relation that can be derived using relational calculus is said to be relationally complete. You're going to specify the relation and then you're going to perform the operations. That is actually relational calculus. Okay, thank you for listening. Thank you.